Thank you, Ben and AGI, for the invitation to present today on flood inundation mapping science. The goal of my talk is to really give a broad overview of what flood inundation mapping science is and types of flood inundation maps, and then the other speakers will be kind of broadening that and bringing it down to a lower level about how these maps can be used. So as many of you know, the US Geological Survey has a very wide natural sciences background in both research and operations. I happen to work in the water division of the US Geological Survey, and kind of the heart of our surface water program are the stream gauges. And those stream gauges form the backbone of a lot of different projects that I'm sure everyone uses day to day, at least I hope. Central to the stream gauge network is our partnership with the National Weather Service and the Flood Prediction Program, and how we can partner to provide those predictions at points at over 4,000 locations on the landscape. Over the last, I don't know, 5 or 8 years, we've been partnering to try and figure out how to spread those point forecasts out across the landscape. Point data is great. It gives you the hydrograph that you see on the right regularly. Those observations are crucial, and those predictions really give people the time that it takes to take action and response during or right before a flood. But how do we move that out onto the landscape? And the answer is flood inundation maps. They can be used in a lot of different ways and created a lot of different ways to create that operational risk and consequences picture that people can really use to take action. So I'm going to actually start with the very basics, which seems really simple. But flood inundation maps and the variety we make them has to do with how we define a flood inundation map. And at its most basic, it's a line where one side is wet and one side is dry under one defined situation. And I think the key with communicating risk is understanding what the defined situation that map was created for or from. And we might want to make flood inundation maps for a lot of different reasons. These are essentially all of the places in the flood risk management life cycle that we can use the exact same map. We can use them in preparedness, planning, what-if scenarios, everything from evacuations to what happens if this road goes out, perhaps, the effects on services. Response, how can we use the gauge and the forecast data to close roads in a timely way? Recovery, understanding our damage assessments and disaster declaration. Mitigation and planning, that's everything from risk analysis to zoning, etc. And kind of a new way to also look at the exact same map, remember, is for environmental assessments and support. And the picture in the lower right of this slide happens to be from the Kalamazoo River oil spill. And we used the flood inundation map product to figure out exactly where they needed to do cleanup because the spill happened when the stream was flooding. So there are a lot of different uses for flood inundation maps and a lot of different reasons that we create them. And you can kind of divide them up into two groups: modeled flood inundation map libraries and flood documentation studies. Looking at the map shown here, you're not entirely sure which one you're seeing. All you know is that there's an area that we are showing as having water in it and an area that we're not. So I'm going to go through each of these in turn, the two pieces of modeled flood inundation map libraries, probabilistic and deterministic flows, and the difference between the two. And then we'll briefly go through flood documentation studies. Ben mentioned the wealth of information, and I have twice as many slides in my downloaded presentation that provide a lot of background information on these. It goes into each of these 5 steps in depth for a hydraulic modeled flood inundation map library. And these are probably some of the most common flood maps that you're going to see. And they all start with a very similar process. You choose your stream reach that you're going to model. You model your given flood height. And we'll talk more about that in a second. And you use those water surface profiles and stretch them out across the landscape to come up with those flood extents and flood depths. And then essentially you can do that once, or you can iterate through a series of modeled flood heights and develop what we at the USGS refer to as a flood map library. Like I said, there are two main types: probabilistic probabilistic flood inundation map libraries are the ones that all the CFMs are going to be exceptionally familiar with. The most common example are FIRM. Basically, the flows or stages that you're going to choose to model are going to be probabilistically determined. You're going to use the stream flow statistics, typically developed at local stream gauges or using the StreamStats application, to bring together the stages that you care about, and in this case, they're specifically tied to risk, and then commonly used to legislate or I don't know what the term is, deal with flood insurance issues. Same modeling method, but different inputs and purpose from deterministic flood inundation map libraries. Created exactly the same. The difference is that we're going to feed in even slices of either stage or flow. The diagram that you see here shows 5-foot intervals. They can really be anything that's dictated by the accuracy of your elevation model that you're using to create that model and to derive those maps accordingly. You can really use any hydraulic model. The most common is certainly HEC-RAS, but any hydraulic model that's appropriate for that area. And we, of course, encourage you to use the USGS stream gauge and rating curve to drive that home and to be able to tie it into that real-time information. These maps, both types, probabilistic and deterministic, are generally robust as long as the base conditions don't change. The deterministic maps have the added advantage that if your probabilities shift, these maps are still going to be usable just very slightly. The third kind of modeled flood inundation map that I'll talk about is a very broad category of GIS-based flood inundation modeling. These can or cannot be hydrologically informed. It really depends on the tool and how they're developed. Generally speaking, these are going to be geospatial only. Things like the bathtub type model and hand is really a poor point. GIS flood tool is kind of a semi-step backwards look. There are lots of different ways to create what areas are going to flood adjacent to the stream line with using just GIS techniques. When you do use these types of libraries, and we'll talk about use in a second, scale is critical for interpretation. The one on the right here is made with a 10-meter library. The one on the left is the 10 meters. The one on the right is a 90-meter, and they obviously have very different uses. For global flood scale, this can work terrific. The last type of maps I'm going to talk about are flood documentation style maps. And these really depict, I mentioned the one defined situation. Instead of that situation being a hypothetical situation, this is showing what actually happened during one event or one moment when it comes to remote sensing. And there's a couple ways to put these together. Generally speaking, we just connect the dots with a GIS model and use elevation data to define that piece. So high water marks, sensors, stream gauges, there's a variety of information that you can use to find out that peak water information for that particular event. The examples that I show here were the Louisiana flooding and the South Carolina flooding from Hurricane Joaquin that essentially show this was the extent of the flooding. These are crucial for damage assessment, understanding vulnerable areas, and really we try to put them together for really extreme events where you've got a lot of damaged infrastructure. These tend to be in urban areas, less so in rural. You can modify the style just a little bit for coastal areas, but it's essentially the same. The last one I'm going to talk about is essentially a flood documentation map, and this is an area that's very much emerging in the current research as more and more technology becomes available to process large-scale imagery, and that imagery becomes more and more available. These maps are becoming widely available, but not necessarily understood or utilized during events because of the barrier to entry, as it were. I'm not a remote sensing expert by far, but I understand the utility that these maps can have to emergency managers to say, hey, this is what the water looked like yesterday. What can we do about it? So there's a variety of partnerships that the USGS is involved with for both satellite, aerial, and unmanned aerial collection. And they bring about all sorts of different challenges and different resolution data. Landsat is obviously going to be a lot more coarse than, say, an unmanned aerial flight over a stream that's got really high resolution. So what you see here are examples of potential flood inundation map products that have to be used very carefully and to understand how they can work together with the traditional flood modeled or flood documentation maps. The USGS is currently conducting research into the library lifecycle. How long should maps last? Expanding what we call rapid FIM testing. So that's saying I have a map that was created with a hydraulic model and high-resolution LiDAR, and I have a map that was created or sensed from a satellite. How can I compare those two and help the emergency manager understand the difference between the two so that they can make the correct decisions regarding operational sources? We are also very concerned, and this keys off of that, is uncertainty, computations, and display. Understanding the uncertainty of these wide variety of maps that people generally just say, this is a flood inundation map, but knowing whether it was derived from a 90-meter satellite collection or built off of a 6-inch LiDAR data set have very different implications for how they should and can be used. But essentially, the goal for us here at the U.S. Geological Survey is to be able to bring a map of any type, and whether that's one map or 50 maps together, tie that with the strain gauge and the flood forecasting partnership that we have with the Weather Service, and bring them to communities in an easy-to-use format. And yes, this shows a modeled flood inundation map library for Ottawa, Ohio, a small community, that put this map together after their flood of record, of course. So we'd like to get these things mapped before they flood. But the goal is to say, this is what you expect to happen at action stage. This is what you might see at minor flooding, moderate flooding. This is what might happen tomorrow. So understanding how to use these maps with the real-time data and the forecast to say what happened tomorrow. And this was the worst case that we ever saw. And to be able to QA some of these pieces in your modeling with real high water marks is a crucial part of the project and how the two types of maps can work together. And with that, I will thank you for your time and toss it over to Maria, who's going to kind of bring the local flair. How do they use these maps during an actual event?